Okay guys, today I wanted to make a video about a different way of doing a Mod-Osc replacement. Normally when you replace a Mod-Osc on a non-protected site, it's a very stressful event because you have to take the path down, you have to take a bunch of covers off, you have to swap crystals, you have to reinstall it on extender board, lots of things that take a lot of time and make it very difficult to do. And very stressful. You even have the possibility of messing something up and not even getting back to where you were when you started. So this is a setup that I created so that I could do it a different way and I didn't have to deal with all the stress of doing long downtimes. What I did was I created a way of having a separate standalone Mod-Osc that doesn't rely on a crystal but relies on a generator to provide the reference frequency that it needs to do its AFC lock. And basically having a standalone Mod-Osc so that when you get to a site you can get this all set up, and when it comes time to do the cutover, all you have to do is swap the cable here, the RF out and the baseband in, and just a few seconds move over to your temporary module and you're done. Now I wanted to talk about how we're doing this here. If you look on the schematic here, we have a local oscillator board that produces a UHF signal from 400 to 460 at 20 milliwatts, and that UHF signal is used with a 15th harmonic to do a phase lock loop locking of your Mod-Osc cavity in your gun diode generator there. So it's basically sneaking in with the Hewlett-Packard to take over the job of the local oscillator board. This allows you to generate on any frequency, and you're not having to worry about doing a crystal swap, and you can instantly be on whatever frequency you want. I'll show you basically how it operates. And I went ahead and I preset up this particular one so that it would be off frequency out of AFC so that you can see how it locks on. So if I come over here and go off, and then you go back over here in my frequency span so I can blow it up and see it. There we go. And there's AFC on, and here it's off. Now, you can see it drifted off frequency there, and when I bring it on, it'll find it and lock it in. And I can do the same effect here by turning off the power out of my HP, which also now it loses its injection, goes out of AFC in there. Turn my Hewlett-Packard back on, and boom, you'll see it grab it and pull it back in. So once you get the frequency dialed in, and it's a very simple formula of figuring out what frequency your HP is. If you're doing a low side injection on your transmit, it's simply the frequency, in this case 6655 minus 70 divided by 15. And that'll give you your frequency there. In this particular case, it's nice even 439. If it's a high side transmitter where the transmit frequency on your transmitter is higher than your receiver, then you'll do the frequency plus 70 megahertz divided by 15 to get your injection frequency that you need to put in. On your your local oscillator board here, there is a simple SMA connector that all you have to do is unscrew, and then you can screw in your HP injection there. No modification to it at all. You simply just unscrew the connector and screw in your HP. I've created a little setup here to so that I can power my Mod-Osc. I have two power supplies, a plus 15 and a minus 22.5, and also have a test gig where I can run off 48 volts and use the Motorola power converters. But these power supplies are a lot cleaner than the old Motorola. And also the HP is infinitely more accurate than the crystal null radio. So when you look at the numbers here, you'll see numbers that have 6 zeros past it, because it's so accurate. So yeah, you get set up, you get your basic carrier going. You can come over here and you can double check your Bessel null transmit deviation. In this particular case, all you gotta do is use your selective level meter here to generate a minus 9.3 signal at 100 kilohertz, and then you can come over and if I can expand, here's all the trees, and basically what you're wanting to do is you're wanting to adjust so that, and if you look at the center null one there, that's the one you're wanting. So set it and go over here, put that on 9.3, and the pot, the potentiometer on these is very sensitive, and it's kind of hard. There we go. That's as close as I dare. So now if you go up and down a level, you'll see it come up, dip at 9.3, then come back up again. So, and now your deviation is set, and you're ready for a transfer. So when it comes down to the cutover time, once again, all you're doing is going to take your RF out and your baseband, move it over, hook up your RF out to your PA, and now you're completely running on this side, and you can come over to your broken Mod-Osc, and you can do in leisure all the changes and fine-tuning, and it just makes it so much easier to do, and you have a guaranteed, in case of disaster, plan already enabled when you get there. So anyway, this is my setup. Hope you like it. We'll talk to you soon.